In this video, we're going to take a look at inverse trigonometric functions. Now the question is, does y equals sine x have an inverse? So if we take a look at this graph of y equals sine x here, we can see that it doesn't. And the reason that it doesn't is that it is not what we say 1 to 1. So what that means is that if I draw a horizontal line, it intersects the graph of y equals sine x repeatedly. So 1 to 1 means that for every single y value, I should get only one single x value. Now, what you might be more familiar with is if I draw y equals x line, and I reflect this graph across the y equals x line, and when we do the vertical line test, it should also only intersect the vertical line once, and it also does not. So the question is, then how do we make it so that it is a function? So to do this, we're going to restrict the domain so that it is 1 to 1. So what we're going to do is we're going to take only a part of the y equals sine x graph. And the part that we're going to take is from negative pi over 2 to positive pi over 2. All right, so with that, we also have a range from negative 1 to positive 1. Now, the notation for y equals sine x, you know, is the inverse is sine with a little negative 1 and then x. However, there is now an alternate notation, and we can write this as y is equal to arc sine x, which is actually a little bit better because then it's not as confusing with a little negative 1, because sometimes we think of little negative 1 as an exponent. All right, so when I want to find the inverse of this y equals sine x graph, what I'm going to do is I'm going to reflect it over the y equals x line. So let me redraw that over here. So when I reflect the y equals sine x graph from negative pi over 2 to pi over 2, I'm going to get something that looks like this. Okay, so we've also now swapped our domain and range values. So now my domain is from negative 1 to 1. And my range is now from negative pi over 2 to positive pi over 2. So now by doing this, our inverse function is now actually a function. So you can think of arcsine, which we'll be using a little bit more often, arcsine x as the angle whose sine is x. Now a couple of notes that I want to put into here is that we need to remember that sine, negative 1, it does not equal 1 over sine x, because the negative 1 is actually not an exponent. 1 over sine x, if you want to write it in that notation, would have to include sine x all in brackets and then with a little negative 1 on the outside. Okay, so this is what 1 over sine x means, but 1 over sine x does not mean with a negative 1 in between the word sine and x. All right, so let's take a look at a few examples. So we have the arcsine of 1, and you might be more familiar with this as the arcsine of 1 is equal to theta, let's say. So that means that we have 1 is equal to sine theta. Or we can also think of this as sine inverse sine with little negative 1. 1 is equal to theta. So remember, when we're taking the inverse sine of a number, we're actually trying to find that angle. So the angle that gives us a value of 1, if we draw the sine graph, so we want 1 here, would be this value here. And we can see that is going to be pi over 2. That means that arcsine of 1 is equal to pi over 2. Arcsine of a half. So what angle will give me an inverse of a half? So this one here, now remember that whenever we talk about exact values, we need to use the special triangles, or we can also use the graph. Now, because we're dealing with a half, this one we're going to use the special triangle. And the one that we want to use is the one that deals with 1 and 2. So we'll place 1 and 2 here because it's sine. That means that this angle is pi over 6. This is root 3. And this is pi over 3. So arcsine of a half, opposite over hypotenuse, that angle would be pi over 6. So arcsine of a half is equal to pi over 6. All right, let's take a look at another one. So this one here is getting a little bit more complicated. So we have the cos and the arcsine of negative root 3 over 2. So we're going to work with the inside first. So the arcsine of negative root 3 over 2. So when we take a look at our triangle, root 3 over 2 means that this has to be pi over 3. Now, arcsine is negative. Now remember where our domain is. Our domain is only from negative 1 to 1, and our range is from negative pi over 2 to positive pi over 2. Now, when we're looking for the arcsine, we're actually looking for our y value, our angle. So that means that we want an angle that's between negative pi over 2 and positive pi over 2. So in terms of quadrants, that means that it's going to be either in the first quadrant or the fourth quadrant. Now, arcsine here is negative. So that means because of the negative, this means that this has to be in quadrant 4. So I'm going to get rid of this one. So that means that arcsine of root 3 over 2, so it's opposite over hypotenuse, that angle will be pi over 3. So this angle here is going to be pi over 3. Or you can think of it as our reference angle. However, because it has to be between negative pi over 2 and positive pi over 2, that angle has to be negative pi over 3, going in the clockwise direction. Okay, so now we have to look at cos negative pi over 3. So cos negative pi over 3, so pi over 3 would be adjacent over hypotenuse, so that would be a half. And in the fourth quadrant, cosine is positive, so this will be positive a half. All right, let's take a look at one more. So here we have sine 3 pi over 4. So sine 3 pi over 4, if we recall, 3 pi over 4 is in the second quadrant. So this is 3 pi over 4. My reference angle is pi over 4. So this is 1, 1, and root 2. So sine 3 pi over 4 is going to be opposite over hypotenuse. So this will be 1 over root 2. So we have inverse sine of 1 over root 2. So now to take the inverse sine of 1 over root 2, I would then now be looking for the angle. And that angle that gives me that will be pi over 4. And it has to be the positive because we are looking for the positive ratio here. And that happens in quadrant 1. All right, now this is how we deal with sine. So what about cosine and also tan? So the inverse cos, we also need to restrict the domain. So what we're going to do is for cosine, we are going to take the domain from 0 to pi. So the inverse, when we draw this, it's going to look a little bit weird. So maybe to help yourself, you can think of this as reflecting over this line here. So when we reflect over this line, we're going to get a graph that goes from here to here. And let me draw this a little bit better, actually. Let's draw this drawing one more time. Okay, so this angle here is going to be pi over 2, and then this part here will be pi. So that represents those points here. So the domain of our inverse will be from -1 to 1, and then our range will be from 0 to pi. All right, now the inverse of tan. So let's draw our tan graph. Looks something like this. And it has asymptotes at -pi over 2 and pi over 2. Okay, so this one actually, when we take the inverse, it still is a function. So this is good. Okay, so the domain is going to be all real numbers. And for the range, it will be from -pi over 2 to +pi over 2. Now, there's a lot to remember. So let's summarize everything in this chart here. So for arc sine x, the domain is from -1 to 1, inclusive. And then the range, we said, was from -pi over 2 to pi over 2. Arc cos is from -1 to 1. The range is from 0 to pi. Arc tan, domain is all real numbers. And then from -pi over 2 to pi over 2. Oops, and then you know what? Let's go back up here. These inequalities should not be inclusive, so let's redraw them without the line, equal lines. Now, arc cosecant, secant, and cotangent, we don't see them as often, but we should still write down the domain to complete our set, I guess. So we have x is less than or equal to -1. X is greater or equal to 1. I've kind of changed the notation. You can still use our bracket notation if you like. And then the range is from -pi over 2 to 0, not including 0 because there's an asymptote there. And this is a union symbol, meaning and, from 0 to pi over 2, inclusive. And then we have x is less than or equal to -1, x is greater or equal to 1, and then from 0 to pi over 2, not including pi over 2, and then pi over 2 to pi, and then arc cotangent, all real numbers, and then from 0 to pi. All right, now the quadrants is what I think is easier to remember. So it's easier to remember the quadrants so that you know the domain and the range instead of trying to memorize all of these different values. So the domain, you would find arc sine would be 1 and 4. For arc cos, it'd be 1 and 2. Arc tan is 1 and 4. Arc cosecant is 1 and 4. Arc secant is 1 and 2. And arc cotangent is 1 and 2 as well. All right, so just to finish off maybe with a couple of examples. So when we look at arc cos 0, we're trying to find the angle that will give me a value of 0. So here is our cosine graph, and the value that gives us 0 here will be an angle of pi over 2. Arc tan 1, the value or the angle that gives us an ratio of 1, if we recall, is our right triangle 1, 1, root 2, is the angle pi over 4. And so on. So you can try the other ones now on your own.